So before we get into the Arduino board, we'll first have to understand the basics. It's based on Atmega16u2 as a microcontroller. Now in the market, you'll find that there are other different Arduino boards. So here, as we begin, we are going to be using Arduino Uno, right? But you'll find in the market that there's a board called Arduino Mega. So the difference between Uno and Mega is the microcontroller that is being used. And so this microcontroller board has inputs, and it has outputs, and these inputs and outputs are programmable, and the board itself is programmable using the Arduino IDE, which we'll cover very soon. And in case we don't understand what a microcontroller is, we could say, simply put, a microcontroller is a circuit board that contains a chip that can be programmed to do many things. So we can have a microcontroller that reads information, and for example, we could have a light sensor that we've connected to our microcontroller, and what the light sensor does, it will tell the controller how well lit or how dim the room is, and the microcontroller can be able to display that data on the screen, so it can tell us this room is very dark or this room is well lit. And another function of the microcontroller is that it can use the data that it obtains from sensors to control devices. So using the same example, we have a light sensor, we've connected it to our microcontroller board, and we're getting an output saying that the room is well lit or the room is dark. Then we can add on to the system another function that says that if the room is dark, then the microcontroller should activate a relay to switch on the lights in the room. And that's how we can use a microcontroller to control a device, so it can turn off and turn on lights based on the darkness of a room. Okay, so to understand how Arduino works, we need to first understand the hardware and the software within which the microcontroller operates. So we're first going to work with the hardware, and with that, I'm going to show you how the board that you have should look like. So if you have the board from the Tectenum kit, your board looks like this. And we're first going to start with the heart of this microcontroller board, which I'm sure you're guessing is the microcontroller. So this right here is our microcontroller, and this microcontroller is an Atmega. Now you might have purchased a different Uno board whose microcontroller might be somewhere here. It's an long horizontal IC, which is the Atmega328. And the difference between this and this is obviously the P, and this P stands for pico power, which just means that this microcontroller, the one we have on our board, consumes less power than the Atmega328 that you might find in other Uno boards. Okay. Moving on to another microcontroller on the board is this microcontroller right here, and we're going to label it here. And this is the Atmega16u2 USB controller. So what this microcontroller does basically is to convert the USB language to IC language that the microcontroller understands. So we'll be loading our code using USB from our computers, but the microcontroller does not understand USB. So you need a controller that can translate USB to IC language that the microcontroller can understand the instructions that we are giving it. Okay. So after the controller, we're going to start from my left, which is here, and then we'll be moving towards the right. So this is a reset button. The reset button has a similar function of plugging in or unplugging the board. So if, for instance, if you want to turn on or turn off the board without necessarily unplugging it from your laptop or from the power supply, then you can press the reset button. And then right next to the reset button is the USB port. The USB port is we use it to connect to our laptop. So you connect to the USB port on your laptop using a USB cable, and the USB port is used to load code onto the main microcontroller, the Atmega16u2 and apart from loading code on your microcontroller, your USB port can also be used to power the microcontroller. Okay, so the function of the port can be either to upload code on your controller or to power the microcontroller board. This is also a power supply, and it's a 12 volts DC power supply. So in case you have already loaded code on your microcontroller and you do not want to connect your USB port, then you can power this microcontroller board using a 12 volt DC power supply. Now you can achieve that by seriesing a number of batteries dependent on the voltage of your batteries to achieve 12 volts DC, and then the 12 volts DC can be used to power the board without necessarily having to hook it on to your laptop. Okay, this right here is a voltage regulator. A voltage regulator is used to regulate or control the spikes in voltage. So sometimes your voltage input might not be ideal, so the voltage could have some spikes, and the voltage regulator works to control the spike so that it doesn't damage your microcontroller. And the voltage regulator works hand in hand with these capacitors, which also help achieve the function of supplying steady power supply to your microcontroller. Next to the capacitors, we have a comparator. The comparator compares voltage level between the DC voltage input and the USB input. So the output of the comparator is what is used by the microcontroller. Okay, and then from the comparator we have LEDs. This is just LEDs are lights that sometimes you can use to determine the function that is being operated. So sometimes when it's on, the on LED will come on. When data is being transmitted or received, the transmit or receive LEDs will come on. When you have programmed for the onboard LED that's normally connected on pin 13 to come on, then you'll be able to see it on here. Okay, then that takes me to the digital pins. So the digital input pins. So the digital input pins are pin 2 to pin 12 are digital inputs, and you will see if you look closely, there's a wavy line before some of the digital inputs, and this just means that these pins are PWM enabled. Okay, pin 0 and pin 1 are used for to receive or to transmit data, and then there's pins here as serial clock and serial data, and these are used for ISCP USB interface. Okay, and then on this other side, before we move on to the analog pins, let's look at the ISCP over here. ISCP. So an example of an application of ISCP would be if you have the board that has the Atmega16u2 which is easily removable. So you want to replace your microcontroller, right? And you want to load a bootloader or firmware on your microcontroller. So you can use the ISCP. You can use it to program your microcontroller directly. Okay, so you can use it to dump bootloader in the case of a new microcontroller. And then moving down, we have our analog inputs. Analog inputs which we can, so if you have a sensor whose output is an analog output, then you can connect it to the analog inputs, which is A0 to A5. Okay, and then lastly, on our microcontroller board, we have this section here, which are the power pins, and these are used to power sensors and there are different types of voltages available. So you have 3.3 volts. You can, if your sensor requires 3.3 volts, then you can use a 3.3 volts to power it, or the 5 volts to power it. That's also available. And then you have ground pins, which are also used in the powering of components like sensors. Okay, yeah, so I think we've covered everything on the hardware of the Arduino. We've covered all the major components. Oh, I left one out. This is a crystal oscillator. The crystal oscillator is used to generate frequency, and the frequency that's generated creates an electrical signal so of the specified frequency. So if you look keenly on your board, you'll see that it has been written 16.0, which means that this oscillator is generating 16 megahertz frequency. Okay, and with that, then I think we have covered all the major components of our Arduino board. And now this brings us to the end of the lesson. So for this lesson, we have covered the introduction to Arduino. We now understand what an Arduino board is, what a microcontroller board is, what the actual microcontroller does. We've understood the major hardware components of our Uno board, and we have understood how the Arduino board is powered up and how power is supplied to the microcontroller.